Lipids Live and Learn!
Yay!
Yes!
Fats are essential nutrients to our body, and our body needs it for everyday function. It insulates the body to prevent heat loss. It cushions and protects vital organs such as the heart, kidneys, and liver. Tanks stored in fat cells act as energy reserves, so it provides energy via ATP, absorbs fat-soluble vitamins such as vitamin A, vitamin D, vitamin K, and vitamin E. However, modern diets contain more fats than necessary, and too much bad fat can cause serious health problems such as obesity and arteriosclerosis. Can you be born fat? People with certain genes tend to overeat and be less active, but this only plays a small role. Smoking during pregnancy increases the chances of the child being born obese or having the genes for it. Children born to overweight mothers and fathers face a higher risk of being fat themselves. Lastly, insulin treatment causes weight gain. When you take insulin, it binds to the receptors in the cell membrane, causing GLUT4 receptors to move to the membrane, and glucose is able to enter your cells, which causes glucose levels in the blood to drop. The cells get more glucose than they need, and the excess is stored as fat. Cells contain little cytoplasm and has a large fat reservoir which stores fat and expands until it is used as fuel. If the body stores more fat than it uses, the fat cells would expand, causing weight gain. If the body is forced to rely on the stored fat reserves, then the fat cells would shrink, causing weight loss. There are two types of fat cells in your body.
Hi, my name is Brown Fat Patel. I am a brown fat. I am composed of several small fat droplets. Also, I am loaded with plenty mitochondria. I am found in newborn babies and hibernating animals, and I produce heat by breaking down fat molecules into fatty acids.
Hi, I'm White Cell Willer, and I'm in all of you! Yeehaw!
Brown adipose tissue has a special function in its mitochondria in that it promotes thermogenesis, which is the production of heat in the body. Thermogenin is an uncoupling protein found on the inner mitochondrial membrane. It uncouples oxidative phosphorylation, and it allows for the protons to run down its gradient in an alternative route without producing ATP, allowing for the energy stored in the proton gradient to be dissipated as heat. Electrons are provided via NADH and FADH2, which are produced from fatty acids and glucose.
Fun facts by Nandy!
What happens when you eat fats? How does the body break it down? The digestion of fats occurs mainly in the small intestines, but a small portion occurs in the mouth and stomach by lingual and gastric lipase respectively. Organs such as the pancreas, liver, and gallbladder also play a key role in the lipid digestion. In lipid digestion and absorption, lipids are hydrophobic and thus are poorly soluble. The enzyme lipase is water soluble and can only work on the surface of the fat globules, so bile is secreted into the small intestines to assist. Emulsification occurs here. This is the breaking up of fat globules into smaller emulsion droplets. The amphipathic bile coats the emulsion droplets and prevents them from reassociating. The newly emulsified fat now has a higher surface area, so then soluble lipase can now work to digest the tag molecules more efficiently. Pancreatic lipase, which is secreted into the intestines, catalyzes hydrolysis of tags at their 1 and 3 positions. Here we see hydrolysis at the 3rd position on the tag molecule. A protein, colipase, is required to aid binding of the pancreatic lipase at the surface of the emulsion droplet. After digestion, the monoglycerides and free fatty acids associate with the bile salts and phospholipids to form micelles. These transport the polysoluble monoglycerides and fatty acids to the surface of the enterocyte where they are absorbed. The monoglycerides and free fatty acids enter the epithelial cells where they are resynthesized into triglycerides in the endoplasmic reticulum. The tag is then covered in lipoproteins, which result in the formation of chylomicrons. The protein coating gives the tag a water-soluble coat, which allows the chylomicron to travel outside the cell. The chylomicron then leaves the epithelial cells and enter the lacteoles, which drain into general circulation.
Fun fact time!
I'm a special kind of fat.
Why is fat so easy to go on? We all want to look like this, but end up looking like this. Main reasons are lifestyle choices, such as stress, poor diet, and lack of exercise. The body needs fats to make vitamins, steroids, and to maintain the phospholipid bilayer. The real reason for weight gain is the deposition of excess fat within the liver. Fats are obtained when they come out of diet. Red meat, fried foods contain tag molecules of triacylglyceride. Consumption of excess glucose in the form of carbs is stored as fat around the body in the liver cells called hepatocytes. When pyruvate is formed in the presence of oxygen, the pyruvate enters the mitochondria via the link reaction. The acetyl-CoA then enters the citric cycle, also known as the Krebs cycle, and binds with oxaloacetate to form citrate. Acetyl-CoA is converted to citrate, which leaves the mitochondria and enters the cytosol. Acetyl-CoA is used to make 3 fatty acid, which will combine with glycerol triphosphate to form TAG. The TAG, formed in the liver, is packaged in the form of lipoproteins and sent to the adipose tissue for storage because the body is in its fed state.
The process uses carbon from the acetyl-CoA to form the fatty acid chain. Also ATP and NADPH for energy. So this is how fats go on easy, but not so simple. The committed step. This step involves the formation of malonyl-CoA. This reaction is a carboxylation reaction because it is catalyzed by acetyl-CoA carboxylase, whose cofactor is biotin, which is the most regulated enzyme in fatty acid synthesis. It is a redeterminant regulatory step and also the slowest in the reaction. It is called the committed step because the substrate acetyl-CoA can either enter the TCA cycle or be used in the synthesis of fatty acid.
Last fun fact, promise.
Weight gain can lead to a person going into a coma, or it can even lead to their death. It can cause diabetes, amputations, heart diseases, and kidney diseases. Inside the stomach, there are fats hugging all your internal organs. First off is your heart. Fats can cause plaque which build up, which causes your arteries to rupture, which leads to a heart attack. Secondly, there are the lungs. Obesity makes breathing difficult since all the extra fats are stored in the belly, which causes pressure around the lungs. The fats around the esophagus can lead to disrupted breathing. Oh my gosh, I can't breathe properly. Thirdly, obesity can affect your brain. While eating meals, you get a dopamine surge which makes you feel good. These dopamine surges are greater in obese people, which cause them to intake more food due to the good feeling they are getting. Obese people can have brain atrophy due to the reduced blood flow, which can lead to swelling in their legs. Arthritis can be formed in joints as well. Obesity can cause psychological problems as well as social discrimination, low self-esteem, depression, and stress. Increased sweating can be caused by the body going into overdrive to cool down. Most weight on your body causes your heart to work more, which can lead to a high blood pressure. And also, your blood sugar levels increase because your body rejects absorbing glucose. So the glucose do not want to go into your cells. They just hang out in the bloodstream, causing diabetes. Fats can also increase the risk of breast cancer. Inside the abdomen, there is a type of fat called visceral fat. It is toxic and it surrounds all your internal organs. It increases inflammation by creating chemicals, and it also affects your cardiovascular system, and it increases your blood pressure. The visceral fat also increases the production of interleukin-6. The interleukin-6 further increases inflammation throughout your body. Your metabolic activity is governed by this excess body fat. Adiponectin, which is affected, tells you to store more belly fat. How can you make excess fat disappear? By maintaining a healthy diet and exercising.
Arteriosclerosis. This is a chronic heart disease resulting in the buildup of fat or lipid material in the inner walls of the artery. The process of blockage. The coronary artery has three basic layers: the tunica externa, the tunica muscularis, and the tunica interna. We are concerned about the inner layer, which is the tunica interna, in analyzing the disease arteriosclerosis. The tunica interna is made up of squamous cells. If a lot of fat is in the blood, this means the blood is high in LDL molecules. LDL stands for low density lipoproteins, which contains a high percentage of cholesterol. The blood transports the LDL from the liver to the nerve tissues and cell membranes for metabolic processes. If bad eating habits are acquired, over time the fat or lipid molecules would settle on the inner surface of the artery. As they settle on the surface, they are absorbed through the epithelial cells, where they undergo oxidation, creating an inflammatory process. Oxidized LDL is toxic. This forms a layer between the tunica interna and tunica muscularis. As this happens, it is referred to as plaque. If bad eating habits are still carried on, the plaque builds up and spreads along the walls of the artery. This causes the walls to become swollen, which swells into the lumen of the artery.
the lumen becomes smaller, therefore the blood flowing through it is reduced. This phenomenon is referred to as arteriosclerosis. Sometimes the epithelial cells could rupture. This activates the platelets to form fibrin threads, which causes a clot to be formed. This blocks the blood from flowing through the artery, and the clot is referred to as thrombosis.
I turn the music up, I got my records on. I shut the world outside until the lights come up. Maybe the streets are alive, maybe the trees are gone. I feel my heart stop beating to my favorite song.